specifically on data related to neural networks and training LLM models. And then, so very specifically, starting out, the thing that I want to highlight, and I've highlighted this multiple times across multiple videos, is that actually building the LLM, like the neural network, isn't very hard at all. It's just code, and it's simple code. So what we're looking at here as far as this code is, you can see here at the top it says it's a BERT-like model. It's exactly what it is. This is like a I think it works out to like 300 million parameter model that we're looking at here with multiple layers, right? And then so this is your typical neural network, like but before ChatGPT 3.5 or GPT 3, this would be like your cream of the crop, right? Like this was like 3 years ago, this would be like your screaming top of the line LLM model, basically. And then so uh, really easy, just simple to set up, right? Now just execute it, and I don't even need GPU to execute this LLM model. And then so really simple and straightforward. It's not going to do anything when I execute it, though, is the problem, right? Until I actually train it on some sort of data. And then what I train it on, like what kind of data I train it on, is up to me from there. But the thing is that I need to train it on data. And then so when we get into that, like the very first thing is like, okay, so we're starting from scratch, right? Like, so let's say that we build this BERT-like model. The very first question would be, how much data do we need for like a BERT-like model? And then so let's look at a few kind of data sets here in Hugging Face to get kind of a good summation of this, right? And then so kind of we'll look at data sets that we would utilize for training a BERT-like model. And then so in a BERT-like model, we're going to look at sentiment analysis a lot. And then so let's see here. We've got this one sentiment data set that has a lot of likes. 190,000 rows, 210,000 rows. Perfect, right? And then so this is kind of exactly what I was expecting, right? And then so to me, this is what I was expecting. I don't know if you were expecting this, but this is exactly what I thought. This is just the one that I picked, right? 210,000 rows. And then so if we're to train this BERT-like model that we have here, this is exactly what we would train it on. And I would want to train it on this data set probably about at least 3 to 4 times. 3 to 5 times is kind of like the where my thinking up front would be, right? There's a little, every single time there's going to be a little bit different with every single data set and every single model, right? But 3 to 5 times on this data set is a general rule. So then 3 to 5 times 200,000 rows, we're looking at like up to like, we're looking at like 300, like up to like almost a million rows, up to up to like 800,000 to a million rows. That's a lot of rows, right? Like 600,000 to a million rows. And so when we get like, it's not a small amount of data is the kind of thing that I want to highlight up front. And then so this is training it from zero, right? Like this is assuming that we're just taking model, we're not fine tuning anything. Like we want it from scratch. Then if you want something from scratch, it's and so this, the other thing to highlight too, this 200,000 row data set, this is just for sentiment analysis, right? Like if we're talking about like our like your actual like large language models, they're trained on like up to like trillions of tokens, like billions of tokens, and then so you're talking about like billions of rows of data, like millions of rows of data. It's like optimal for training those types of models. It's an obscene amount of data that is required within this, right? And I don't think people understand like that obscene amount of data. And so when the question comes up as to whether or not models act like these models actually learn, or are they actually just like sponging from the data, like it boils down to this, right? Because it's always so much data that is required. And then so if it's so much data that the model has to take in, and the model's bad at generalizing overall, then it raises the natural question of, is the model actually learning from the data? And then there's split sides on both sides of the debate. I fall on the side personally, and I'll put it flat out, that they do learn from the data, right? I have like a lot of statistical tests that I've done, and a lot of analysis that I've done personally leads me to believe on the side that they do learn from the data. They're not actually they're not just directly copying the data. It's not that type of thing. Uh, and so that's the side of the fence that I lie on. But I understand the arguments 1,000,000% as to anyone that's on the other side of the fence with that, simply because of this equation, right? Because it's it's a very clear argument to make. Like, okay, if it's actually learning, like, why do you need 200,000 rows of it just for sentiment analysis for it to pick up a concept? And that, like I don't know. Like, I mean, it's to me, like, I guess that what my answer to that, my honest answer to that would be, like, look at a baby, right? Like, people think like it's of things in like adult human terms, but an adult human has been through a lot. I've been through multiple years of experience, right? I started off as a little baby, and then so if you get a little baby to perform sentiment analysis, it's not going to do it. Like, of course not, right? Because the baby needs more data. It needs a lot more data. It needs 18 years to grow up. Like, that's a lot of data. And then so kind of breaking it down, like, you can't fault AI for being that same way, right? That's kind of my take on it. But again, I understand the other side of it. So going back to what we're talking about here overall with this video, this is the from absolute scratch, right? So 200,000 rows at a minimum if we're training like a BERT-like model. If we're training like actually like GPT type model, we're getting into billions and trillions of rows and tokens. But that's not most people's use case, right? Most people's use cases, they want to fine tune these models. So they want to go from an actually like existent model, like a llama model or a chat GPT, and they want to give it more data, right? To refine it. And then so the question becomes like, how much data do you need to give in that instance? And I think that's the question that a lot of people ask. And there's a lot of back and forth on this particular question, right? Because there's a lot of people that are like, in a lot of instances, like, oh, you don't need to fine tune your data, or there's RAG tuning that's available, or all of these different options, right? Flat out, my big thing with a lot of these statements that a lot of these people make is I don't think that a lot of these people that make these statements have honestly trained a lot of models. And I'm just putting that flat out. And I'll like flat out, I've trained hundreds of models at this point. Like, and then so that's where I come from on this. And so from my experience and my perspective on this particular subject, what I've found is that fine tuning a model makes a massive difference. And then but there's limitations with data, right? It all comes down to these data limitations. You're feeding the model data at the end of the day, and then you need to feed it massive amounts of data, more data than you think, right? And then so it's those two things combined that I don't think most people fully wrap their heads around. So the very first thing, like, so I've gone through. I guess the next thing to point within this is kind of to showcase a little bit of this for you, and I'll just look at like this is my particular Hugging Face here, right? And then so I've got a lot of data sets here, 43 data sets that I've uploaded to Hugging Face. And then a big thing that I want to point out here with this is that you'll see like almost every single one of these data sets that I have here, like these are like all of these, they're at least 400 rows, 400, 500, and 750, right? Like that's the sweet spot for me. Like no less than 400. If you're putting in less than 400 rows, for a fine tuning job, you should expect suboptimal results from that, just flat out. And then this is kind of like interesting and like, so if you look at OpenAI's documentation, they say that you should start at 50, right? I think they do that to make money. Like, I have data sets here where that start at 64 rows. I have 50 row data sets, 100 row data sets. I put some of these out, right? And I've tested and I've trained models on these data sets that I put out, of course, right? And then so the thing that I can tell you is that these low row data sets, they don't do anything. Let's like, for example, so you can see here like these two most recent data sets that I have here in what we're looking at here, this Maritime 64 and the Maritime 200, right? And then so that's number of rows. I started off with 64 rows because this is a client job. So I got 64 rows from the client, and then I said I need a lot more rows, and I got 200, and then we're still at the point now like I need more rows, right? And then so that's kind of the break down that, and I go through that a lot, right? It's hard to create, like, it's easy to conceptualize you need 500 rows of data. It's easy to create 100 rows of data, like, and then that's where you get like these 50 to 100 rows. It's like, yeah, that's easy to do, and then you feel accomplished, and it's like, okay, yeah, I did it. Oh, there's a big difference between doing 100 rows of data and then 500. It just gets really tedious. You don't like doing it overall. Like, a lot of things go into it because you need to clean this data, right? And then so that's the big thing that like people don't realize how tedious it is to come up with this amount of data, and how much it impacts the performance of the model overall if you don't do this. And then so just using the examples here, if we train on Maritime 64 and somebody takes a look at this, and for example this client did, they said it's absolute garbage. And I said, you're right, it's 64 rows of data. Like, it's not enough to actually for the model to be performant and for it to see it. And then when they took a look at the model, they agreed, and you can see it within the model's performance, right? That it's just, it barely touches what the baseline model does. And then like, so it's like, okay, you can see, like, okay, let me give it some more. And then so with 200, and then you go from that 64 to 200, and you can see a massive leap in performance. But then it's like, man, there's still a lot missing here. We still got a lot more to go. And it's like, yeah, you're right, because we need to get up to ideally 500 plus rows. Ideally, more ideally, 1,000 rows. Like, 1,000 rows is your very good sweet spot for these types of commercial models as far as a fine tuning job. And it's not expensive overall to fine tune these models, even on 1,000 rows. Like, you're talking tops like $30 to $50 to fine tune these models on that. And there's a lot of ways to cut those costs down, even. So, like, there's no reason not to, except for the fact that it's hard to, at the end of the day, come up with so many rows, right? And then so kind of the last thing, I want to give you kind of the full breakdown that you need for data in this instance, right? And then so the last thing that I kind of want to highlight here is that, so when it comes to data, there are a few tools that I've built out like personally. And then so the hardest part for a lot of people then, like, so once you get all of this down, and then you get your data, and then you got to enter CSV files, the next thing that people run into, and it was hard for me for a while too, was like, okay, I need to format this data, right? And then when you start like running into multiple different models, what you'll notice is that each individual model has a little bit different of tweaks and ways that it needs to be formatted. And then so here we've got Chat Bison, Cohere AI, Gemini Pro, and I think I've got like ChatGPT, maybe not labeled, OpenAI, and then yeah, so I've got like all the basic models, right? For and I built this out for myself because what this is essentially I take my CSV file of my data set that I want to train these models on, and I just dump it into here, and then it will auto convert, and then I get my file, and I get my JSON-L file, and then so I can train models from here, and then from here you can see I've got the Vertex AI open here as well. Again, I'm training models all the time here, right? So here's just two models, two trained models that we're looking at here, and one failed trained model, which happens a lot still all the time. But so it's this is the process that I use. It's this simplified process of like this saves me a lot of time, right? Just going through and then auto converting, and then it is tedious to upfront once you're getting it. If this is your first time getting into and training a model, this will be like a hard thing for you, is getting and converting this data. But once you realize and you get a system like this, and you realize that every system is a little bit different, and you kind of just work through, look at the documentation, understand exactly, okay, I'm OpenAI, they're looking for, and their structure is very specifically where you need the system message, and then you need the role, the system, you provide the system content, and then so it's role, user, content, and then row with the prompt and the content. Like exactly, they lay it out in the documentation exactly what you need to do. You just need to read the documentation and understand what it is in the documentation. But each one is a little bit different, right? Or a lot different. And so you can see some of these have a lot more code and a lot less code, right? But overall, the big thing here that I want to end this video on is that uh, there's a lot of misconceptions around data and training models overall. And then so very first one is it's cheap to train the model overall. It's easy to convert and to get the data into the format that you need it to. It's easy, very easy to create 50 to 100 rows of data. It gets increasingly difficult to get the actual ideal number of rows of data that you actually want, which is 50 to 1,000 or 500 to 1,000 rows of data. And the last thing is that you want it to be of exact examples of what you want the model to output, right? Like very exact. And then so let's again a few highlights here to end this and to take this into account. Like the models themselves, they can't count. They're not going to perform basic logic on the same level that humans do, and there's like they are very faulty with regards towards a lot of logic, especially if you're not fine tuning them on those types of things, right? And then so um, with all of that in mind, it's very imperative that you're giving it the ideal number of rows that it needs, and like the quality of rows that it needs, like very specific tasks and very specific. Like if you want it to produce copy, then you give it this is the exact copy that you're going to produce, and this is it, right? And like the exact size of the copy. Like don't train it on like a bunch of like 2 pages of text and then ask it to produce like paragraphs outputs. It's going to struggle with those types of things by doing even that, right? So you just have to pay attention to all of these things and look at the equation a little bit differently than you would if you're training a human on these types of things, right? And I just highlight these because these are the big things that I run into with clients a lot, when it comes to this overall. So just highlighting this when it comes to data, and then hopefully when it comes to data, this video has kind of given you some sort of clarification. And if you like this type of content, please like and subscribe. Thank you very much.